All right, last set of notes for today. We are graphing linear inequalities in two variables. This is similar to when we graphed inequalities on a number line where you had to make the choice between an open dot and a closed dot, and then did the arrow go to the right or did the arrow go to the left? But since we're on a coordinate plane, we can't do an open dot versus closed dot. So instead of that, we do, if it has an equal sign, we do a solid line. If it doesn't have an equal sign, we do a dashed line. So instead of a solid dot, open dot, we do a solid line versus a dashed line. And then you want to check a point, and here's the key though, not on the line. So you take a point, you plug it into one of the inequalities. If you get a true statement, that's the side that you want to shade. If you get a false statement, then you want to shade the other side. So this is the, instead of does the arrow go to the right or does the arrow go to the left, we have to decide which side of the line we're going to shade. Okay. So to graph the inequality y is less than 2x plus 3, I graph it like normal. I just say, oh, my y-intercept is at 3, my slope is at 2. So I put my y-intercept at 3, slope up to the right 1. Now here's where we make the difference. Oh, there's no equal sign. It's just strictly less than, so it's a dashed line. Then I pick a point to check. If I can, I really like to check the point 0, 0, because 0 times anything is 0. So I'm going to check the point 0, 0, which means I plug in 0 for y, and I plug in 0 for x. So I get 0 is less than 2 times 0 plus 3. Is 0 less than 3? Yes! Happy! 0 is less than 3, and there's the point, so that's the side we want to shade. Alright, so for this one, I decided to graph it using the x and y intercepts, as it's in standard form. So if I plug in 0 for y, this term disappears. So if 9x equals 18, then divide by 9, x equals 2. So my x-intercept is right there at 2. Then if I plug in 0 for x, this term disappears. If negative 6y equals 18, divide by negative 6, and y equals negative 3. So there's my y-intercept. Now we pay attention to the fact that it's not an equal sign, it's an inequality, but it says less than or equal to. So since this has the equal sign with it, this is a solid line. And then I need to check a point on the line, and just to show you it doesn't have to be the point 0, 0, I decided to check the point negative 4, 0. So I'm going to plug in negative 4 for x and 0 for y. So 9 times negative 4 minus 6 times 0 is less than or equal to 18. This equals negative 36, and negative 36 is less than or equal to 18. And the point was right here, so that's the side we're going to shade. All right, and last one, 5x is less than negative 20. So I divided both sides by 5 and got x is less than negative 4. So remember, if there's only one variable, it's either a horizontal line or a vertical line. So x, here's the x-axis. We need to cross the x-axis at negative 4. So this is going to be a vertical line. Every point on this line has an x value of negative 4. There's no equal sign though, so notice we made it a dashed line. And again, I like to check the point 0, 0, so I chose to check that. So I plug in 0 for x. There is no place to plug in the y, so we just don't worry about it. And we go, is 0 less than negative 4? No, it is not less than negative 4. 0 is bigger than negative 4. And it's over here on the right side, but it was a false statement. This point does not work. We don't want that point, so we shade on the other side of the line where the point is not. And that's it for Monday's notes.